Question number 3 is not really any dramatically different than questions 1 and 2. The only difference is I'm telling you that y is the same thing as 2x minus 6, and then I'm telling you y is also the same thing as 4x plus 4. So how you actually go about the substitution here is really totally up to you. If you want to say y is the same thing as 4x plus 4, so come up here and change y into 4x plus 4, you can do it. If you want to say, well, y is the same thing as 2x minus 6, so I'm going to go down here and change y into 2x minus 6, you can do it. In the end, the result is the same. So what I see here is that y is the same thing as 4x minus 4. So I'm going to go into the top equation and change y into 4x plus 4. So 4x plus 4 is the same thing as 2x minus 6. Solve the equation. Again, if I'm solving the equation, I'm using the rules for solving equations we always have, which say variables on the left and numbers on the right. So we've got 4x on the left side, that's good. 6 on the right side, that's good. 4 and 2x, though, those need to flip to the opposite sides. Again, when I want to move something to the opposite side of the equal sign, I do the opposite. So I kick 2x over to the left side, I subtract 2x from both sides. Right? I want to go ahead and kick 4 over to the other side. So I'm going to subtract 4 from both sides. So I do that, and I've got 4x minus 2x is 2x's. Negative 6 minus 4 is negative 10. Well, if 2x equals negative 10, that means x has to be negative 5. Because 2 times negative 5 is negative 10. So I now know that x is negative 5. So now what I want to do is go back up to the top, pick one of my two original equations, and change x into negative 5, and that's how I'll find y. It doesn't really matter in this particular question which one you pick, because they're both exactly the same length, and really the work here is going to be identical in terms of what we do here. So let's just go ahead and pick the top one here. So I've got y equals 2x minus 6, and we're changing x into negative 5. So I've got y is the same thing as 2 times negative 5 minus 6. Well, 2 times negative 5 is negative 10, and negative 10 minus 6 is negative 16. So the solution here, x comma y, is negative 5 comma negative 16. All right, now 4 is just a little different because it looks a little different, but other than that, it's really not any more challenging than any of the three previous questions here. We've got 3x plus 6 is the same thing as 3y, and then I'm telling you that y is the same thing as 7x minus 1. So if y is the same thing as 7x minus 1, I'm going to change y in the top equation into 7x minus 1. So I've got 3x plus 6 equals 3 times 7x minus 1. Solve the equation. Well, that's fantastic. All right, we're down to one variable, just like it's always happened in the previous set of questions here. One variable solved for the one variable. But we've got a little bit of simplification to do here on the right side that involves the distributive property. When I do that, I'm going to end up with 3x plus 6 is equal to now 21x. 3 times 7x is 21x. 3 times 1 is going to change into 3. All right, well, let's simplify that. Again, we know our rules for solving equations tell us to keep the variables on the left and the numbers on the right. So the 6 and the 21x are the two troublemakers here. That's what we're going to have to move. So it doesn't matter which one you move first as long as you move them. Opposite side, do the opposite. So I'm going to knock 6 off both sides here. And at the same time, let's knock 21x off both sides. Now, if you're looking at this already with this kind of a bit of curiosity here, yes, what you're seeing develop here is not inaccurate. It's not going to work out to be a whole number solution here. I've got 3x minus 21x, that's negative 18x's. And over here I've got negative 3 minus 6, which is negative 9. So a multiplication problem to be solved by division. Again, not a whole number answer here. When I divide across by negative 18, x is equal to, ends up being equal to 1/2, or if you want to write it as 0.5, you can write it as 0.5. All right, so a bit of an odd answer, but it works. I'm going to now go back to one of my original two equations and change x into 1/2 and continue solving. So I look at this bottom equation and I say, let's change x into a half. So if I do that, I've got y equals 7x minus 1. I'm changing x into 0.5. So I've got 7 times 0.5 minus 1 is what y is. Half of 7 is 3.5. 3.5 minus 1 is 2.5. So to find my solution x comma y, it's 0.5 comma 2.5. Again, x value first, y value second.